Hello everybody, how are you? Today we'll talk about quadra. What about quadra? Quadra is a figure such as that A, B, C, D. We have four sides, not equal lengths. This figure, sum of interior angle of this figure, it was 360. And if we move from A to C and draw the line segment, this line segment is a diagonal. Okay, this figure is a quadral since it has four sides and four angles. How many triangles were formed? We have 1, 2, and we can divide it by draw line segment DB. DB is a line segment and add a diagonal. How many? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 triangle. Again, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 triangle. The sum of the measure of the angles of the quadrilateral is 360. Now we will talk about a rectangle. This figure is called rectangle. We have four sides. Each two of the sides are equal in length, such that ABCD is a rectangle and EB equal DC, BC equal AD. And if we draw two triangle or two diagonal here, we can divide the two triangle by diagonal BD. DB is a diagonal, and the diagonal AC equal to DB. They are equally lengths. AB equal DC and AD equal BC. Write it. And what about the diagonal AC equal PD and AC. Okay, AC not perpendicular to BD. BD we can write BD equal AC again, or we can write a congruent if you put this sign here, so we will have the congruent. You can write equal or congruent. And what about the measure of angle C? Measure of angle C equal measure of angle D equal measure of angle of A equal measure of angle of B equal 90 degree. Measure of angle A equal measure of angle B, measure of angle C, measure of angle D equal 90 degree. It's okay. Opposite sides congruent. All angles are right. Opposite sides are parallel. We know AB parallel to DC, line segment AB parallel to line segment DC, and AD parallel to BC. And what about square? Square, all sides congruent. All angles are right angle. All angles are right angles. Opposite sides parallel. Look at here, ABCD square. We have four angles. The measure of them equal 90 degree. Measure of angle A equal measure of angle B equal measure of angle C equal measure of angle D equal 90 degree. And AB is equal to BC is equal to CD is equal to DA. All sides are equal in lengths. And if we draw a diagonal DB and diagonal EC, we know two diagonals are congruent, two diagonals perpendicular and equal lengths and bisect each other, such that BD and EC intersect at M. So we know BD equal to AC, and BD line segment BD is perpendicular to AC, and MP equal to MD equal to MC equal to MA. Okay, again about square, we call it, this figure is a square. All sides congruent, all angles are right angles, opposite sides are parallel, such that EP parallel to DC, BC is parallel to AD. And what about parallelogram? Parallelogram, opposite sides congruent, opposite sides parallel, opposite angles congruent. Look at here, A, B, C, D is a parallelogram, AP parallel to DC, and BC is parallel to AD. BC equal to AD and AB equal DC. Two diagonal not equal lengths and not perpendicular, and not perpendicular. Okay, I'll write it here. But two diagonal bisect each other, such that they intersect at point M, then DM equal MP and AM equal to MC. Okay, opposite sides congruent, opposite sides parallel, opposite angles congruent. It's about parallelogram. Okay, what about rhombus? Rhombus, all sides congruent, all sides congruent, opposite sides parallel. About rhombus, look at here. What about rhombus? Rhombus, we have two diagonals, perpendicular, and not equal lengths. They are intersect at one point, such that M. We have A, B, C, D, and this point M. Two diagonal bisect each other, two diagonal perpendicular. So AC was perpendicular to DB. Okay, AC perpendicular to PD, and not equal lengths. Four sides equal lengths, all sides congruent, opposite sides parallel, BC parallel to DA and EP parallel to DC. Okay, and what about trapezium? Trapezium, exactly one pair of opposite sides parallel. We have two types of trapezium, such that isosceles trapezium. Here we have trapezium, isosceles trapezium. We have four sides. They are not equal lengths, but pair of them was parallel. And in isosceles triangle, we have two sides equal lengths, such that BC and AD equal lengths, and AP parallel to this DC. So in the congruent in this trapezium, we can call it trapezium or trapezium. Exactly one pair of opposite sides parallel, AP not equal to DC, but AB was parallel to DC. And we can draw another figure about trapezium. We can draw right trapezium. We can draw right trapezium, such that this figure. And we have exactly one pair of trapezium parallel, such that A, B, and CD was parallel, and this measure as angle measure of it will be 90 degrees.